Hello, I'm Eric Hanley, an automation specialist with ES&E, and in this video segment we'll be working on Studio 5000 Logix Designer, and we will review the 4 programming editors as well as trending capability within the software. But before we get started, please like and subscribe to the ES&E TV YouTube channel for all your automation and online training content. The first editor, and still the most common amongst Rockwell equipment, is the ladder editor. Ladder logic was the original style editor created because it most closely resembles relay electrical drawings. In addition to looking like an electrical drawing, the ladder editor has the most features, making it the easiest to troubleshoot and diagnose. One main feature is the visual representation of logic, which is commonly referred to as power flow. This allows you to see what expressions are being examined and where within the logic you are executing without any additional code required for debugging. Ladder logic always aligns input instructions to the far left of the rung and output instructions on the far right of the rung. Since it is so easy in nature, it typically is the easiest to learn for people new to controls. The next editor is the function block editor, or FBD. Function blocks come in handy for instructions that do not exist in ladder, such as the enhanced PID instruction or PIDE. Function block is more of an object-oriented programming interface where you need to physically draw connections between the instructions. Function block code is executed from left to right and from top to bottom, so placement of the instruction does matter. With the improvements made to the editor starting with version 32 in Logix Designer, there is now no backing tag needed for most of the instructions, which helps save memory. Also, the wire routing now shows jumps anytime a vertical line crosses a horizontal line. In previous versions, the wires would make a 4-way intersection, making it very difficult to follow the logical flow of the wire. The other drawback to function block is that the sheet size is limited and cannot be expanded like you can in the other editors. This means once you run out of room to add blocks, you need to create a new sheet. The next editor that resembles either C++ or JavaScripting is the structured text editor, or STX. This is becoming a more common editor as many people are learning other scripting languages. The structured text editor has pre-built code snippets that provide an example with syntax of the 5 most commonly used instructions. The 5 instructions are if then, case, do for, do while, and repeat until. In addition to Rockwell providing these code snippets, they have improved upon the features of the editor by adding numbered lines, live values for the tags while online, and an online syntax checker for pending edits. Also, if you are not using one of the pre-built code snippets, pressing the F1 key to launch the STX editor help menu, then searching for structured text syntax. This will give you all the proper syntax for all of the commands that are used in the editor, as well as provide examples of how to implement the command. The 4th and final editor is called the Sequential Function Chart Editor, or SFC. SFC creates a flow diagram with steps, actions, and transition conditions. Steps are just identifiers of where in the chart the current code is executing, but each step can have an associated action. Actions allow you to execute code while the step is active, and it uses STX for its programming. Then, to move from one step to another, you have to pass through a transition instruction, which also uses STX for programming its true condition. Many people prefer to use integers inside ladder logic or structured text to accomplish the same thing as the SFC. The main advantage of the SFC editor is that the larger visual representation of the sequence of operations. Now that we have reviewed the 4 editors, we will discuss the trending capability within Studio 5000. Trends are created as part of the project file and allow you to graphically see atomic data types such as bools, dints, and reals. You can sample those tags as fast as 1 millisecond for debugging purposes. One major reason for the speed of the trend would be to watch an I/O signal that keeps causing a nuisance trip which stops the machine. Trends will show a change that may not be visible within the program editor if the change occurred quicker than the update time of the logic scan. Trends can add multiple tags within one trend, and it will store data into the RAM of the processor so that you can go back and review the trend without having to watch it continuously. But if you close the trend or stop the trend, then the data will be lost since it is not stored in permanent memory. When looking back into historical data in the controller, RAM will stop adding the current data, so keep that in mind as you're looking back at historical data. The trend object is configurable when you double-click on the trend in the project organizer, and it will launch a property editor. This is where you can add multiple pens or tags, and you can change the color of the pen and the width of the line to make it more visible. This is also where you specify the data type of the pens, such as analog or Boolean, as well as the X and Y axis scale. The last feature that is advantageous is to trigger the trend on the start of an event of something happening. So you can now start and stop the trend from a tag or logical expression. This can be convenient if you know after a specific event happens that an error will occur, but you haven't narrowed down the exact condition, or if you want to see how a piece of equipment is operating to ensure it's running smoothly. There are several other configuration options within the trend, but it's a very useful diagnostic tool, especially when it comes to high-speed applications. Thanks for watching, and if you have any questions, please contact your local ES&E account manager or automation specialist.